Hey everyone. Just about to get started here. If you are going to be attending the second part of the workshop at 3, make sure you have your dev environment set up coming in if you plan on actually doing the workshop. It's perfectly okay to just watch me go through it. I will do it. But if you want to participate, either follow the instructions here to set up your dev environment, or we have pre-provisioned VM instances of dev environments that you can log in through a browser on. And so if you want one of those, and if you don't have one set up, by the end of this, you probably want one of those, go ahead and raise your hand, and I have some folks here who will pass out logins. All right, fantastic. Yeah, just keep them raised. We got plenty. And I'll ask that again at the end of the talk. Okay, I was actually going to ask some questions and have people raise their hands, but that was kind of poorly thought out, given that I have you raising your hands for slips. So what I'm going to talk about today, my name is Phillip Wittrock. I'm a software engineer at Google, and I am a Kubernetes owner. So I help maintain the product. I'm also a member of the Kubernetes steering committee. What I'm going to talk about today is how Kubernetes APIs are implemented. And so I'm not going to talk about all the kernel stuff and the container stuff. And instead, I'm really going to talk about how do we build abstractions in Kubernetes so you can work with higher level abstractions instead of low level abstractions. And I'm just going to give a quick refresher here so we're all on the same page. Kubernetes is a cluster orchestrator. It runs containers in a cluster for you. And when I talk about nodes, those are the machines that are going to end up running your containers. When I talk about pods, those are actually just where your containers are running. A pod is essentially a container or a set of closely coupled containers with environment variables and storage and that sort of stuff. Users typically don't create pods directly. Instead, they have higher level abstractions that can manage the creation of pods for them. For instance, replica sets have a count, and you can just say, I want n instances of pods that look like this, and the replica set will go ahead and stamp those out for you. There's even higher level abstractions, such as deployments, that can take care of things such as updating a replica set. And so you can do a rolling update where at some point in time you want 2 versions of pods out, right, as you shift traffic and load from an old version to a new version. And all these APIs, the deployments, the replica sets, pods, and stuff, are called resource types. And the objects and the instances are called resources. There you go. Okay, so I put up this slide to make things sound complicated and hard so that when I break them down and make them simple, you leave feeling like you learned a lot and feel good about yourselves. But it's all true. Kubernetes have these properties about them that are really important to understand when you're working with Kubernetes, because it's really going to help you understand how to debug the system and how to make it do what you want. And so as part of this talk, I'm going to use a pizza metaphor that I got from Jeff Sika at U of M yesterday as feedback. And I'm going to try and describe Kubernetes APIs kind of like ordering a pizza and kind of not like ordering a pizza. So first of all, Kubernetes APIs are declarative. And so typically you would declare a resource in a file. So this is a deployment instance declared in a file that has 3 replicas running Nginx with a particular name. And so you'd run kubectl apply on this, and that would go take whatever's in this file and make it match what's in the cluster. Declarative is different from imperative in that if you wanted to make a change to this, say increase the replica count, you wouldn't say increase the replica count by 2. You would just put replicas 5 in here, reapply it, and then it would go make those changes for you. So this is kind of the opposite of Ansible approach, is how I've heard it described. And it's different than, say, Docker run or running a process on the command line where you want to start something. Instead, this is managed more like code where it's checked into a source control management system, ideally. And that allows you to do fun stuff like have it reviewed before it's rolled out and really understand what's being rolled out. Be able to roll it back because it's declarative. If you just revert the change to make it look like it did before, it will automatically push it to look like it did before. And you get a nice audit record. So those are some nice things about Kubernetes APIs being declarative. So I'm going to go through an example of what happens when you run kubectl apply on that file. So the user creates this file called deploy.yaml. And they run kubectl apply on this file. Not create, not update. They just say, whatever's in this file, make sure the cluster looks like this. And kubectl is first going to go discover what endpoints exist from the API server. So it's important that the client doesn't have a baked-in knowledge of like, here's all the APIs that exist and here's how I talk to them. Instead, it just asks the API server, hey, what are your API endpoints? And then it goes and looks for this particular one that matches this. If it doesn't find one that matches this, then it will throw an error. But in this case, it will. And then it will go update the object. Once that's updated, some magic is going to happen and you got pods running. Okay. So we're going to talk about what that magic is, because that's kind of the fun magic here. So that magic is in controllers. Kubernetes APIs are asynchronous. And so when you apply that deployment change, it's going to return to you after it stores it, right? It will do some validation, schema validation, but it's not going to actually validate that it can pull the image, for instance. So what's going to happen is after it's stored, the controller is going to go and pick it up, see that change, or see what you stored, and then it's going to actuate it. Controllers are decoupled from the API endpoints. So the API server, where you go and write the deployment file to, does not know about the deployment controller, which is actually going to implement the API. What happens instead is you have some process running in the cluster, and that says, I want to know anytime there's a deployment change to the API server. And it doesn't say I do something with it. It just says, tell me about any time there's a create, update, or delete for these things. And so this way, the whole system is actually decoupled and modular. Okay. Kubernetes APIs are also observable. So as I alluded to, what the controller does is it sends this watch to the API server. That's what it's called. And it's like a subscription to events. And when it gets an event, it will then take the namespace and name of the object it's trying to reconcile, in this case a deployment, and go look up the state for that deployment and compare, this is what the system should look like against what it actually looks like. So controllers are going to watch the objects and resources they control. So the deployment controller is going to watch deployments. They also watch resources they create, update, delete, or manage. Right? So if a deployment creates replica sets, the deployment's also going to watch replica sets. That way, if something goes and whacks the replica set, it can go recreate it. Or if a status changes in the replica set, where for some reason a rollout isn't healthy, it can detect that and then take action. The other half of the controller, in addition to the watch, is the reconcile. And this is really the core piece of what drives the Kubernetes APIs. The controller gets this namespace and name for an object or the key for it, and it reads all the state of the system, and then decides what it needs to do. So this is different than getting an event, where it says, hey, there's been a scaling event to increase replica count by 5, and OK, I'll go create some more things. Instead, it looks at the entire state, and so maybe there's multiple scaling events and a rollout, and oh, by the way, this bad thing happened, and we need to work around it. And then makes certain decisions to push what the user said they want into the cluster. OK, so the pizza analogy here is that controllers are asynchronous. So when you order a pizza, you say, hey, I want a pepperoni pizza or something like this. And you don't wait on the phone until the pizza is delivered. Right? Instead, what you do is you hang up, and you kind of wait for things to happen. Right? And if the pizza doesn't come, maybe you call the guy back. But otherwise, you just wait for it to happen. And the level-driven I don't have a great pizza analogy for, other than that maybe if you change your order, that they don't like give you 2 pizzas. Okay, so I'm going to do the controller workflow example here. So this is a workflow for some update comes into the API server. And the API server will then send a watch event to the controller. So the controller said, give me events. API server says, OK, this event happened. Controller then goes and reads the cluster state, so the deployment and the replica set, and sees what's actually there. That is the replica sets, and compares it to what the deployment thinks should be there. And then it's going to go make some changes. Those changes may be just updating the status to say this is what the current deployment status is. Or it could be creating replica sets or updating them or deleting them or these sorts of things. So we're going to go back to that apply example, but this time we're going to try and fill in those question marks that cause the pods to happen. So user applies the file, and this goes and creates the deployment. And the API server will send a watch event to a deployment controller. The deployment controller will see that there is no replica set for this deployment. So we'll say, OK, I need to go and create that replica set. And that will get stored. And the API server is going to send a watch event for replica sets, because one just got created. And the replica sets controller is going to subscribe to those. And we'll see the replica set come in. And then it will say, OK, I expect pods to exist. So then it will go look for those pods, see that they don't exist, say, OK, I must create the pods. So it will send the create pod request to the API server. The API server then sends watch events for pod creation. And there's this piece called the scheduler, which is responsible for scheduling pods to machines. And it will see that these pods, these new pods exist. And it will look for a node in the pod spec. And it won't see one, so we'll say, OK, I must schedule this to a thing and write that in. And it will update that pod. And nodes are also listening to pod events. And so when this comes in, the node will say, hey, that belongs to me, but I don't see the containers running for this pod locally. So I will go start running those containers, and then I'm going to go update their status. Right? And then the status can get propagated up through these pieces. So the pod status into the replica set status into the deployment status through a series of watches. So update looks pretty similar. We apply the deployment YAML file after making some change. In this case, say we change the image. So we want to do a rollout. That will then send a patch to the API server. So it will say, OK, change these parts of the deployment. Send a watch event to the deployment controller. This time, it will find a replica set there, but the replica set won't look the way it wants it to. And so what it'll do is it'll say, we need to create a new replica set that has the image we want in it. So it will go ahead and create that new replica set. And we'll say, but we don't just want to blow away the old one and then while this stuff is spinning up. We want to do a rolling update. So we're going to begin to scale up that new replica set and scale down the old one. And that will send 2 updates to the replica set controller, one for creating the new replica set and the other for updating the existing one, which will then create and delete pods respectively for each of the replica sets. And then this looks pretty much the same with the node needing to stop running the old pod, terminate it, begin running the new pod. OK, so before I move on, are there any questions on controllers? Yes? Yeah, so typically there's 1 controller per API type. Controllers typically are designed so that they listen to only deployments, for instance. So that means you got, for every API type, you have typically a controller. And then there's things such as the scheduler and the kubelet, which are not, we don't call them controllers per se, but have a lot of the same behaviors. Right? So we've talked about controllers and this magic that actuates the Kubernetes APIs. And it seems really important because all this orchestration is happening through this data being passed around, that this data is well structured and well understood by all the parties that are consuming it. So I'm going to talk a bit about the way resources are structured, because there is consistency to them. And they're broken down into roughly 4 parts, sometimes 3 parts. And that's type metadata, which is highlighted in blue there, an object metadata, which is highlighted in red, and a spec, which is highlighted in purple, and then a status, which isn't shown here. OK, so the type meta has a group, in this case apps. And the group is really just like a package in Java or Go or something like that. Then it has a version. Versions are very interesting. What versions do is they allow you to have backwards compatibility when you change defaulting behavior or the structure of the object. They also can communicate stability of an API, like alpha, beta, GA. But what's really cool is that if you create an API and you don't like the way it looks, right? So say I have a pizza, we have our Hawaiian pizza, and we didn't put ham on it originally. We just had pineapples, right? And then we realized, you know what? Hawaiian pizza is really better with ham. And every time someone orders a Hawaiian pizza, we'd really like just to put ham on it instead of telling everyone, order Hawaiian pizza with ham, right? But what's going to happen is my kids don't like ham, and I'm going to order Hawaiian pizza, and it's going to show up with ham on it. And then I'm going to be like, what happened? We are all not going to eat dinner tonight because there's ham on this pineapple pizza, right? And so by having a version, you can say, OK, I want the V1 pineapple pizza, and that's going to make sure that there's never ham on that thing when I order it. And then we can make V2 pineapple pizza, which will come with ham by default. In both cases, you can always order pineapple pizza V1 with ham, or pineapple pizza V2 without ham, and you end up getting the same thing. But it allows us to change these defaults so that people aren't surprised when we change how we want things to look. It also allows you to change the structure a little bit. So if we had a field that was, say, 1 value, and then we realized that actually needs to be a list, in version 1, we could add a list, right? And now you have a single value for the field and a list, and users kind of have to figure out how to fill it in, right? And we could have it say, you put the first value in the single field value and then the rest in the list or something like that. But really, you don't want it to look like that. Really, you just want a list. So when you do V2, you can just have the list, right? And that way, people don't need to go back and refactor their existing deployments and have them break if they don't do that, right? But the new version looks nice. So that's what the version is about. And the last piece is the kind. So the kind is just basically the common name of the resource type. And so when I say deployment or replica set or pod, that's really just referring to the kind. So the next piece of the 4 pieces is the object metadata. So while type metadata is metadata about the API type, the object metadata is about the instance or the object. And it has a couple interesting things. It has the namespace in the name, or in some cases just a name. And this is the primary key to the object. So when you look an object up, you can do it by namespace and name, and you can't have 2 objects with the same namespace and name exist. There's also something called annotations. So annotations are arbitrary key value pairs you can attach to an object, like a map. And they do something really interesting, which is they allow you to extend the schema of the object, right? So if you have a deployment and you're like, I would like to have tooling that works with a deployment, that I can extend it in some way. And as part of that tooling, I actually need this schema data to be attached to the deployment. How do I do that? Well, you can actually take an annotation and put that data in there. And now that when you read that instance, your tools can go look for that annotation value and pull the data out. And you've effectively extended the object. The other thing it has are labels. Labels are also arbitrary key value pairs. But the difference between annotations and labels is labels are indexed and queryable. So if you want to label a particular object with some property, you can then say, hey, API server, please give me all deployments that have this particular label with this particular value, and it will return them to you. And as I'll go into later, this is really useful for connecting objects in the system, because there's relationships between them. Deployments may manage multiple replica sets may manage multiple pods, and labels, because they allow you to query for objects, allow controllers to find these relationships. All right, so there is a final two parts to the for are the spec and the status. So the spec, this is most of the time where users spend thinking about. And it has like the replicas, for instance, and the pod template and the image and all this sort of stuff. And it's really what you want running in the cluster. When you say I want to create a deployment, really what you're saying is this is, you're filling out the spec and saying, go make it look like this. In addition to that, most objects have a status. And what the status has is what the current state of the system is. So if you have 3 replicas, what you probably want to know also is how many of those replicas are running or at the most recent version or these sorts of things, or being started. And so the status is where the controller communicates back to the user or other parts of the system the current state of the object. Are there any questions on resources? Yes?
I'm not sure if you can hear me, but you said that to reference an object, you need a namespace name pair?
Most of the time, so there's objects that are not namespaced. Like nodes, for instance, don't have any concept in a namespace. But for the purposes of this workshop, you can think of the namespace and name pair as the primary key for the objects you'll be working with. And the question was, sorry, you need a namespace and name pair as the primary key for an object. And the answer is, for some objects, it's just name, and for some objects, it's namespace name.
My question was actually, don't you need the kind in that as well? I think I've created
Yes. You are correct. Yeah, so it's the group version kind for a given type, I should say. That is the key. That's correct. OK, so now that we've talked a bit about the resources and how they're structured, and the controllers and how they work and their relationship, we're just going to dig into sort of the nitty-gritties of how does that controller actually go and generate those objects. So this is a diagram of a deployment and its relationship to a replica set it's created, and then its relationship to 2 pods it's created. And the deployment is set labels on the replica set, and then has this selector. And the selector allows the deployment to query that set of labels and find the replica set. And the same thing, the pod has a selector for, or sorry, the replica set has a selector for the pods it's created. So that allows when you reconcile a deployment to go find a collection of objects. But you also want to trace back from object to the one that created it. So one thing, for instance, is when you get an event for a replica set, you're reconciling the deployment in the deployment controller. You're not reconciling the replica set. So you need to go find which deployment actually owns this object, because the change in the replica set needs to be propagated into the deployment. And you can do that through an owner's reference. So this owner's reference points back at a particular type and namespace name, and I believe it has a UID there too. The owner's reference allows another cool feature of Kubernetes, which is when you delete your deployment that has then created replica sets, and those replica sets created pods, you would really like the replica set and the pods to go away. right? So how does that happen? And if you have an owner's reference on the object, and then the parent goes away, there's a garbage collection system that can then go find those and automatically delete them. So this saves essentially just work on API writers from having to get all the cleanup work correct. So that's how we generate objects. So how do we update them? That's easy, right? Actually, it turns out it's a little more tricky than you might expect. The spec is actually shared across different parts of the system. And so while you may create a service, for instance, from your apply, you may apply a service.yaml, it creates the service. You say, hey, I own the spec, right? It's all in this file. The cluster may actually populate important data into that object. So service, if you look at it, has a cluster IP that gets populated. And if you just blindly try and update the object by taking the one from the file, for instance, or one that you generated and say, go use this instead, it's actually going to fail or delete that data. And in the case of service, it will fail, saying, hey, you can't delete the cluster IP once it's set. So what you need to do is from a controller, you need to really do the read, set the fields the way you want them to be, and then do the update. And you get a nice optimistic locking to make sure that you don't stomp on anyone else's changes. And if you're using tooling, say your kubectl apply, that's why we do a patch. Okay? We just want to change the things that we know about instead of taking whatever's there and replacing it with what we have. So the way kubectl apply does this is it stores a copy of the last thing it applied in an annotation. Right? So this is where that annotation extending the schema comes in. When it applies something, it writes the annotation, here is the file that I used to create this thing. And so now the kubectl tool can differentiate between, can go and look back in history of the last thing it applied. And when you delete a field, it can go figure out, hey, this new file doesn't have this field that used to exist. So I'm going to go ahead and delete it. Right? But if you never specified a field by cluster IP, it doesn't go and try and delete it, right? Because it knows that it was never something it created. And so it ignores that stuff. So it does a diff between the last one it stored and the current one, and the one in your file. Then it also does a diff between what's in the cluster and what's in the file, and creates a patch from that. OK, so we can create objects. We can update them from controllers. And now we need to start being able to be smart about how we update things. Like how do we respond to replica sets becoming healthy when we're doing a rolling update, right? And respond to changes into conditions in those. And so one piece of this is the status that I talked about earlier, and another one is events. So talking about status first, status typically has a list of key value pairs called conditions. These conditions are how we tell other parts of the system about the current state of the object. And this is a pattern we use instead of a single state, because sometimes a resource is in multiple states at the same time. For instance, you are scaling up while you are also doing a rolling update, right? And this is because it is asynchronous and level-driven that you can have multiple things going on at the same time instead of serially doing things. The other useful tool we have for observing the state of objects is events. So events are objects you can create and then attach to another object. And so while status will tell us, right now, 3 replicas are healthy out of 5 or something like that, it won't tell us that like 5 minutes ago, it just brought a new replica online or these sorts of things. Or it was unhealthy and it became healthy. And so events give us a view back in time. And so you can attach them to another object and publish them. And then as a user, you can use kubectl describe on an object, and it will go get you the events for the object and then give you the status and spec and pull out different fields. Synchronous defaulting and validation. So I mentioned that we do some defaulting and we do validation. And how does that work? These are done synchronously. So when you create the deployment, if you don't specify replicas, it will go and set the replicas field for you when it stores it. And that way, it doesn't change underneath you, right? And we don't have something in the controller trying to interpret an empty value. We just upfront say, OK, here's the value for this thing. And this is done by the API server. There's also validation that's done by the API server. So this is simpler validation. And I can look at certain changes like, oh, the cluster IP is being changed. We don't allow that. But it can't do other things like I'm going to pull this live Docker image and make sure that it's there and accessible. And when you're writing Kubernetes API extensions, which I'll talk about in a second, you can do both of these through webhooks. So the last thing I'm going to talk about is how Kubernetes APIs are extensible. And so I talked about different abstraction layers, about how you have pods, but users don't want to create 1,000 pod instances. They want a replica set that does that for them. And then you have replica sets, but shifting traffic between two different replica sets with different pod templates is kind of a pain, right? So we want an abstraction on top of that that knows how to manage multiple replica sets and do rolling updates. So we created deployments. And that's kind of where it ends for us right now, right? Is these generic APIs that allow you to run any sort of container with certain common properties. And there's also stateful sets and deployments and daemon sets and jobs. And there's a couple of them. But that means when you want to run something like MongoDB, for instance, you have to go find a blog post about how to run MongoDB, right? And then you have to construct this stateful set and this service, and then put the right things in there, and then specify the right arguments, and specify the right environment variables. And so it's kind of a hassle, right? And it's hard to read, and each user has to manage all that complexity. And there's tools to help with this. One is called Helm, which is a templating, and people can publish packages called charts that have all the information for creating, say, a MongoDB instance, and it will spin up a stateful set and a service for you. But these aren't Kubernetes native APIs. They don't work with kubectl apply or any of the tooling. And they don't have the controller logic that Kubernetes APIs do have, right? So with a cloud-native Kubernetes API, you can actually look at a specific change, and instead of just updating a raw value as you would with, say, a template, you can say, OK, before I do that, I need to do this, this, and this, right? Before I change, instead of just stamping out a new replica set with the same image count or the same replica count and deleting the old one, I'm going to take a series of steps to get from one state to another. And so you can build all this logic, operational logic, right into a Kubernetes API that you publish yourself. So these are often referred to as operators, the operator pattern. And there's a talk here, I think yesterday, about operator SDK. So there's more and more tools coming out about building these operators. And that's because building the controller and building the resource is not trivial. There's some real challenges to it where the controllers themselves have actually very complex logic about how they cache data from the API server and set up watches and reestablish watches if the watch times out, and does all this logic and set up queuing, message queuing for you. And so to address this complexity, tools such as KubeBuilder and Operator SDK have published libraries to make it simple. And in the second half of this workshop, we're going to be using one called KubeBuilder, which is a subproject of API Machinery and the Kubernetes project. And what KubeBuilder does for you is it sets up and initializes a Go project for you, so you have the right set of dependencies, the right project structure, the right main file, so it looks like everyone else's. And then provides libraries for high-level abstractions, so you just say, I want a controller, I want it to watch this thing, and here's the reconcile implementation. And it will actually generate the stubs for that for you. So while the libraries are pretty simple to use and boil it down, you still need to hook it into your system someplace, right? And you still need that initial method name. And you still need to inject into it a client, for instance, right? And that sort of wiring and boilerplate is a nice place that either just gets copy and pasted all around, or everyone does slightly differently, and then you don't have consistency. So it'll generate that scaffolding for you with some stubs. OK, so going back to what we first talked about in the slide, Kubernetes APIs are declarative. You don't say how you want things to change. You just say how I want them to look now. They're asynchronous. So when you go push the changes, the system is going to go figure out how to make it happen, right? One nice thing about that is if it breaks, the system is still going to go figure out how to fix it, right? Instead of a single operation that it completes and it's like, OK, I'm done. They're level driven. I didn't touch on this too much, but instead of looking at individual events, they just look at the current live state and the current desired state, and then figure out how to match those two things, right? And so it won't, if you push 3 different images and say change it, change it, change it, it doesn't try and complete each rollout. It just goes to the latest state that you should have. They're observable with watches, events, status, and they're extensible. So you can create your own Kubernetes APIs with CRDs and controllers. And so I'm going to end just a few minutes early so that everyone really has a chance to go get this set up, because when I do the workshop next, 45 minutes is not a lot of time to build from end to end a full operator. And I don't want to slow us down by setting up the workshop or setting up the dev environments. Are there any questions? Yes. The slides are not in the repo. I will be publishing them and adding a link to the repo afterwards. Yeah. All right, let me repeat the question, make sure I got it right. So you have like a queue messaging system or something like that, and you want to auto-scale based on the size of the queue. Yeah, that might be a good solution for an operator. There's probably a couple ways you can do that. So there are like horizontal pod autoscaler exists, which knows how to scale things like stateful sets and deployments. And you might be able to hook into what metrics it uses to do that auto-scaling, and so that might be simpler. But if you could also do it through an operator pattern, and especially if you had logic beyond just I want to increase the replica count based on this particular metric, it'd be a good choice. Yeah. Yeah, great. I was expecting that question. The operator SDK, I think, so they're converging, or at least I hope they're still converging. There is a library set called the controller runtime, which is what KubeBuilder uses. And as part of the workshop, you'll see this as an import statement. Operator SDK, I believe, is moving towards being built on top of controller runtime. And so the idea is that while KubeBuilder and Operator SDK may have different opinions about maybe how they scaffold out a particular structure, under the covers they're using, like the direct libraries you interact with are the same ones. That is the hope. And I looked at the Operator SDK repo yesterday, and they have examples of using the controller runtime. And it looks, the scaffolding actually looks very, very much like KubeBuilder. So we are seeing convergence there. Also with, I think with Operator SDK, but I know with KubeBuilder, KubeBuilder just gives you those libraries, the shared libraries, and does scaffolding. And it doesn't have any tools that you need to like build it. Right? So when you build it, you use make or use go build or these sorts of things. So you could create your project with KubeBuilder, stub out some stuff, and then delete KubeBuilder forever, and everything will work from there on out, and you just have to write your own stubs for things. All right. So again, set this up, and if you don't have a dev environment set up, raise your hand. We can come by with a username and password for an account to log into and get you set up that way. Has anyone had any trouble setting up their dev environment, by the way? OK, great. Any other questions? Yeah. Yeah, that would not surprise me at all. OK, I don't think KubeBuilder has Windows binaries published. So you're going to probably want to use one of these things. This guy will bring one to you. Is that a question? Okay. Yeah? Oh, sorry, hands. That's confusing, isn't it? All right, thanks, everyone. Hello? Hey, hi, everyone. All right, welcome back. So what we're going to do now is we're going to take everything that was talked about in part 1 of this workshop. If you weren't there, don't worry about it. But if you were there, you get to take that knowledge about, OK, here's what a controller is, here's what a watch is, here's what a reconcile is, and here's what a resource is, and actually get hands-on experience applying those, solving a problem, which is to make an API for creating MongoDB instances. Yes? Yes, I can. This is also, everyone should be able to go access this GitHub page, and everyone should just pull this up now. It's, if you have a slip, you can get it through that link. Here, oops. OK, workshop.kubebuilder.io. Go pull this up, because you'll want to be able to copy and paste from the instructions there. So what we're going to do is we're going to build the MongoDB API. Right? And so at the end of this, you should be able to write a kubectl YAML file that says the group is databases, the version is v1 beta 1, the kind is MongoDB, set the replicas and the storage, and then run apply, and then we'll actually bring up a stateful set and a service that are running those. The same way deployment brings up replica sets. So steps we're going to go through are we're going to first use KubeBuilder to create stubs for the controller and the resources. KubeBuilder will have already set up the project for you if you followed the prerequisites. And if you haven't, or you're having trouble with that, raise your hand, and we can have someone come by and help you. But hopefully, if you're this far, you finished those. So KubeBuilder will have set up the project for you. And now we want to go ahead and create an API. And so we tell KubeBuilder, create API. We'll give it the group, and the version, and the kind, which are what define the resource type. And then it's going to ask you, do you want me to create the resource for that? You say yes. And it'll say, do you want me to create the controller for that? You say yes. And then we're going to complete the filling out the spec of the resource stub, updating the watches, and updating the reconcile. For each one of the steps, there's a break glass. There's a completed solution inside this repo, so you can click on that, and then you can say, see what the code is actually supposed to look like. So I'll click on that here, and it's kind of small, but you can see that there's some code here that shows you how it's supposed to look. So step 1 is going to be to update the schema and add a replicas and a storage field to it. Step 2 is going to be update the watches, right? So we want our controller to be have reconcile run on the MongoDB instance whenever a change happens for a stateful set, a service, or the MongoDB instance. And the third thing we're going to do is have Reconcile go ahead and create that stateful set and create that service. And that's probably going to be the hardest part. And there's a bunch of notes in here about how to do that stuff. And when you do that, I'll have given you utilities that go and provide a struct that has the stateful set to create, and provide a service that has a struct that has the service to create, so that you don't have to figure out and fill all that stuff in. Because that's not the interesting part. You could go home and you could figure out, how do I run MongoDB on Kubernetes and a stateful set, and then go fill in that struct yourself or change it. And then we're going to go and run it inside a cluster. So I'm going to go through this step by step with you. If I'm going too slow, just blaze ahead, because I'm going to wait for everyone to catch up. If you get stuck for whatever reason and can't get the break glass working, you can either raise your hand, or you can just follow along and you can see what it looks like when I do it. So is everyone able to read this? I have an IDE set up here. I am lucky in that I can actually use an IDE because I have it set up locally. If you happen to be using a slip, I'm sorry. I hope your Vim skills are strong. And so what I'm going to do is I'm going to go ahead and say, from within the project, within the KubeBuilder project, go ahead and create the stubs for those APIs. Say yes, yes. And so it says writing scaffold for you to edit. I'm writing a types file for you. I'm writing a test for that file. So it will check the storage and make sure it works correctly. I am writing the controller stub for you and a controller test for you. And then it will go and generate some code, and format, go vet it, generate the CRD, which is how the resource gets registered, and RBAC rules, so you can run it inside a cluster and have access to the APIs. It'll run the tests, and we'll go build it. So just everyone go ahead and do that if you haven't already. And that's going to create this types.go file. And it says, edit this file. And it has down here the MongoDB struct that has a type meta, which we talked about earlier, the object meta, which we also talked about, the spec, and the status. And so it's our job to go and define the spec and the status. And we'll forget about status for now. We'll just focus on the spec. So I'm going to insert in here the fields we want. So this is going to add an optional integer field for replicas and an optional string field for storage. And there's an explanation on the README about how to make these optional, because there are a couple things you need to hit. OK, so that's it. My schema is defined. We have a MongoDB resource we can create with a replicas field and a storage field. Now let's give everyone a minute to make sure they're up to speed. So the next step we're going to do is we're going to add the watches for the MongoDB instance. The way this is done is the controller was stubbed out for us here. And it has an add function. What the add function does is it's called to register the controller with the main program. And you can create multiple controllers by running the kubebuilder command over and over again. And they all live inside the same binary. And this actually has some nice properties because it allows caches to be shared, which are heavily relied upon, actually. And this is how we run things in Kubernetes, is we have a single controller manager binary where all the controllers run in. So we'll go and open that file and look at that add function, which is called And that's going to call this controller new thing that creates a new empty controller for us, right? And passes in a reconcile method. This looks a little bit weird. It's mainly constructed this way so that you can stub out different pieces for testing. Makes it a little easier. But ultimately, this add function gets called, and it passes in this reconciler in a manager. So we have a new controller that's going to call the reconcile, and now we would configure that to watch MongoDB instances, services, and stateful sets. And so it's stubbed out for us actually watching MongoDB instances because, of course, you're going to want to do that. You're writing a controller. You said you wanted to write a controller for MongoDB. And so as this queue request for object essentially says, if I see an event for this thing, go ahead and do a reconcile on that thing using that same key. And then it also stubbed out this other thing for us. And it turns out what the stub did is it created a controller that creates deployments. Because most of the things people want to do kind of look like, I want to create a deployment, right? Maybe I want to create a stateful set. Maybe I want to create a deployment. Maybe I want to create a couple things. But essentially, I want to create some sort of Kubernetes resource and then manage it, right? And then when a change happens on that thing, I want to be notified. So we have this watch statement here that has a deployment. And it says in queue request for owner. The owner type is MongoDB. And the kind is a deployment. So I'm going to change that to be a stateful set. And then I copied it, and I'm going to change one to be a service. And I changed the package name here. And that's because stateful sets live in the apps v1 package, which is imported at the top. And services live in the core v1 package. So that's it. We have now successfully created a controller that does some reconcile we haven't implemented yet, but does get triggered anytime there's a change on the MongoDB instance, on a stateful set, and on a service. But it will always reconcile the MongoDB instance. So that is step 2. And there's documentation here about those watch functions, right? Because I kind of just showed you how to scratch the surface, but you can implement arbitrary ways of mapping objects to one another. So instead of just through the owner's reference, you can do it through something you concoct, shoving data into annotations or different label selectors or any other number of things. OK. Is anyone still working on the watch? I'll give it a couple more minutes, because we got 30 minutes left to complete this, and we're about halfway there. So I'll just say the next thing we're going to do is we're going to create the reconcile. And the reconcile, what we want to do is create a stateful set that runs a MongoDB container. It's configured a specific way. The details of that stateful set contents are not the focus of this. And also create a service that matches it if they don't exist. If either one does exist, I want to compare what are the ones that exist look like compared to the ones I think we should have. Does the storage match? Does the replicas match? And if they don't match, what we want to do is change the fields on the live ones to match what we expect them to be. This is different than just overwriting them completely, because the service has a cluster IP that we don't want to wipe out. So we want to keep that on there. And I've provided these functions here for you. So if you are using one of the slips to log in, or you cloned the prereqs project, then you will have this package that has those functions in it. And you can go look at the code and see what's being created there. If you did not clone the prereqs repo, and you did not use a slip, but instead decided to set one up from scratch using kubuilder init, which is a great thing to do, you will not have these utilities that are here. And so instead, what you need to do is you need to go and copy these into your project, right, and create a package util package, copy that Go code in there, and then make sure the import matches. So whatever Go package you're using for your project, just make sure that that's what you import. Okay, so I'm going to scroll down here to the reconcile, and it has all this please update me stuff. There's this RBAC thing, which we're going to ignore for now. Then there's the first thing it does is it gets the MongoDB instance that it has the name and namespace for. Right? So it calls this get. And the way this is done is you provide an instance of the struct to the get method. It then goes, looks it up, and writes it in there, and then gives you an error if it doesn't exist. Right? So if it's not found, then we just return and say, OK, that thing's gone. Garbage collection will handle deleting the stateful set in service. We don't need to do anything. Otherwise, we found it. And it's stamped out code that creates a deployment for us here. And we don't actually want to create a deployment. What we want to create is a service. So we're going to go ahead and delete that. I'm going to say, instead, generate service. This is a function that will go ahead and create a service for us. And I'll just open this briefly. And it has similar code that we saw before, where it creates a struct and returns the address of that struct, right? And fills in some stuff like the port number and the name and the label selector. So right now we have a service instance called deploy. Maybe we should change that. Let's call it service. OK. Again, I'm sorry if you're on VI and don't have the search and replace down. It might take you a little bit longer to go ahead and replace all these references. So the first thing it's going to do is going to go, the existing code goes and looks up, hey, is there a deployment before I create one? But what we want to do is see, is there a service before we create one? So we're going to instead change this to go look up a service. Right, so now we change the type. What it fetches is based off the type. So the client goes and looks and sees this is a service. It will fetch a service. It was a deployment before. It was going to fetch a deployment. So it goes and tries to get this thing. Says, OK, if there is a not found error, that is, it couldn't find the deployment, then it's going to go ahead and create the service. Otherwise, it did find something. And so the stubbed out code does something very stupid or simple, right, which is just does a deep equals on the specs and sees if they match. And this doesn't even work that well because a lot of the fields get defaulted. And so it's kind of a heuristic, but it helps guide users. We want to get rid of that. Instead, we want to check the fields for the service. And so I have this function here that will copy fields from the service you generated to the service that was read. And then return true if they didn't equal each other, if it did any copies. Because if they weren't the same, you're going to have to update it. So it copies the fields, and if they changed, go ahead and call update. So what have we done? First, read the MongoDB instance, check if it's there. Then go figure out what service we should be creating for this MongoDB instance to run it. We're going to set the controller reference here. This is like the owner's reference that I talked about in the other talk. So make sure that the service we create points back to the MongoDB instance and it gets garbage collected. Then go read that service, see if we can find it. If we can't, go ahead and create it. If we can, go ahead and update it by copying the fields from the one we generated to the one we found and calling update. So we're going to do the same thing for our stateful set. So this is going to take the instance. It's also going to take the replicas and the storage. And the reason it takes the replica and storage as separate arguments is because when I wrote these functions, the type hadn't been defined yet, so I can't accept it as a type and have it compile Otherwise, if you were to refactor this code now, you could just delete those as additional arguments and have it take the MongoDB instance. Then I need to go and do a copy-paste, update all over the place. All right, did I get everything? That's always the challenge, is making sure you don't copy and paste too much and you got your search and replace, human-driven search and replace down. So we should now have a reconcile method that will be called with the reconcile request containing the name and namespace of a MongoDB instance in response to any changes to us, a stateful set with a MongoDB controller, a service with a MongoDB controller, or the MongoDB instance itself. And then it will go and create these things. So I'm going to go ahead and do make star get. I'm going to go check no custom resource definitions running. So in a minute, I'm going to go and kick this off by having it install, that is, generate the CRDs, and then kubectl apply them to write them into the cluster that I pointed at, and then say make run, which will run that controller locally as a process on my dev station. Normally, when you do this, you would publish a kubectl YAML file that has all the CRDs and has the controller as a container compiled and built in, and someone could kubectl apply that YAML file, and it would just run in their cluster, and they don't have someone with their laptop running the controller. But when you're doing development, it's a lot easier to skip that step and just have it run here. And that works because the controller sends the watch to the API server. So the API server doesn't need to know about this thing. And you don't need to have the cluster being able to reach out and connect to my local machine. The machine connects to the cluster. Is anyone still working on updating the reconcile function? OK. I do realize it takes a while to go and update all those things. It's quite challenging. Or rather, I found it time-consuming when I was doing it myself. OK. So we're going to call make install. It says I generated CRDs. It generated RBAC file, RBAC rules, which we won't be using because we're not running in cluster. We're running locally. We can see the custom resource definition there. Now I'm going to do make run. Now this is going to start a blocking process, which is the controller that creates those things, or that actuates this resource. You can see it there, starting the command. And I'm going to send that into the background because it blocks. So now it's running in the background, and I'm going to go use kubectl apply to create an instance. So one thing that KubeBuilder does for you is it goes ahead and spits out a sample file for you whenever it creates that resource. And this just makes it really easy to skip the step of looking up this particular format, maybe copying, pasting a deployment, and then changing the API version and the kind and the metadata and all this stuff. which is always just an extra step that you don't learn much from. So this is the goal, right, was to be able to define this file here that just says, hey, I want a MongoDB instance with this replica, with one replica, and this much storage, and have the API go and build this thing, right? And ideally, continue to watch it and do whatever it takes to make it, keep it healthy. So I'm going to take that, and I'm going to update the sample. So now the sample has the real fields that we're using. And then I'm going to run kubectl apply. Okay, and what I expect to happen, because the controller is running in the background, is it's going to spit out something saying, hey, I'm going and creating these things. So there you go. And it actually says it's updating these things too. And that is because my copy functions don't do a great job of actually detecting changes because of all the defaulting. There's actually a lot of fields that get defaulted, so when it compares them, they don't line up correctly. And so if you were to go in and do a better job of this, you'd go look at that copy function, and then you'd figure out what gets defaulted and where, and then you'd make sure that you didn't false positive an update on those things. But for now, we're happy, because this is a workshop. So oops, I didn't push that change. You can do this. So I have a list of things you can get. You can actually do them all in one line, comma separated, no spaces. Services, stateful sets, pods. So what I just ask for is give me the MongoDB instance and the services that you have and the stateful sets and the pods, right? And so it spits them out. You can see there's one MongoDB instance there with an age of 1 minute. We have the service with the cluster IP. There is the stateful set that has one desired replica and one current replica. And then it has a single pod here. And the ready 2 of 2 means there are 2 containers running in that thing. Not that there's 2 replicas. And the status is running. Mine's running right away because I've already pulled this container. For the rest of you, it may say container creating for a while as the pod pulls down that image and then begins to run it. But eventually it will run. And if it doesn't, let me know. So you can do fun things now like kubecontrol logs and then give it the name of the container and then go see some logs. And let's go really check and make sure that thing's working. So I'm going to go show you something that typically I don't recommend, which is an imperative workflow for Kubernetes, but it works well for demos, which is kubecontrol run on some image. And so this is just going to give me a shell, a bash shell, using the MongoDB instance in the cluster. And so I'm going to say Mongo. I'm going to take that service IP, because this is internal only. We're not publishing this externally. I'm going to say 2717 port. And then you can see you have the shell. So the thing's running, and you can connect to it from inside the cluster. And this is set up using the blog post that's linked on the README. This is not a production setup. It is a demonstration setup. OK, so cancel out of that. Cancel out of that. And so that's we've proven that we have the MongoDB instance running. In just under 30 minutes. So is anyone still working on any of the steps that I've shown so far? OK, great. Mm-hmm. Could someone bring a mic over, please? Any of my runners around?
So I'm doing the describe of the pods, and I see it pulling the Mongo down, containers down. Is that that's going to take a while those are being pulled down. So if I try to run the other command, the get MongoDB with an S, that's just going to fail until those are done and it's up. Is that correct?
Yeah, that's correct. If it does not say pods running and says anything other than pods running, since there's image pull, container creating, these sorts of things, the logs will not work and the run will not work.
Okay. Thank you.
Okay, so if you've done all these steps, you have a set of code with a reconcile, a watch, and the ability to go and look and say, yes, this thing is working, and now is your chance to go and play around and see if you can break it or see if you can make it cooler, right? And there's a bunch of additional activities listed on the README, and you can decide which ones you want to do. Some of the interesting things to try are what happens when you delete the stateful set. If you just do kubectl delete stateful set and give it the name of that stateful set that the MongoDB instance created, what do you think is going to happen? Anybody have an idea? No one? It's going to, well, let's find out. I don't know either. I'm going to be surprised. So it's currently 5 minutes old. And you can see there's a bunch of text that fired, right? Because that's the controller running in the background. It said creating stateful set. And then updating it because it doesn't diff correctly. And you can see now there's a stateful set running that's 14 seconds old. And that's because it's listening to the updates, right? And it gets a delete event. And then it goes and triggers that reconcile function. The reconcile function goes, says, where's the MongoDB instance? Or where's the stateful set instance? Doesn't see it. Goes ahead and recreates it. You can see from the messages, if you're careful, that it doesn't create a service because the service already existed. And so this is where you can add interesting things that would have self-healing properties, right? And this is the level-based system that I talked about in the first part of the workshop, where the controller isn't designed to say a MongoDB was created. I will therefore go and create a service in a stateful set. Instead, it says something happened. Go figure out what needs to be done, right? It's a very smart little helper. Another thing you can do is, I've just specified a couple fields here, the storage and the replica count. But there's other things you might want to control, like the port. And so you can go and figure out how to go add a port to the spec and go update it. Or another fun thing to do would be, we didn't fill out the status at all, right? And so when I do kubectl get-o YAML, go DBs, right? It doesn't have any information about the state of this thing. And so we could populate that saying, hey, the service is available at this IP address, right? And we could say or here's the cluster IP of the service the MongoDB is behind. And you could even say whether or not those pods are ready. For instance, one of the comments was, if the pods aren't running, do I expect the running and execing the MongoDB to connect to the service to work? And the answer would be, I gave is no, but you have to go do kubectl get pods to figure that out. And if you have a bunch of stuff running, like a bunch of different pods for deployments and stateful sets that are not this thing, pulling that information out is kind of a pain, right? And so you could have the MongoDB controller go ahead and look at the status of the stateful set when it reconciles and go publish data back. There's a bunch of other things listed here. adding schema validation, publishing events, scale endpoints, doing more interesting things with the API, updating the tests. A challenging task might be to do a check for when the version of MongoDB changes, for instance, and maybe that some data migration has to be done as part of that, possibly, right? Or if for something you're operating, when you scale, you need to do a resharding of data manually, right? If you're operating a stateful system like that, then you can detect that change in scale and then actually trigger resharding of data as part of the API itself. And this is why they're called operators, is there's operational logic when running these things, and you can just bake that automation in. OK, are there any questions, or does anyone need any help getting to this point? Awesome. All right. I expected this to take everyone a bit more time. In my test runs, they usually bumped up to about 50 minutes. Would you guys like to see me try and get this running in cluster? All right. I have not practiced this, because I was not planning on doing this. This was mainly just for people that finished it early. So you get to see me try and do something unrehearsed. So first, I'm going to foreground this thing, kill it. And next, I'm going to say make Docker build. And I need to find out what project I'm running in. All right. So gcloud config. Do something. kubectl. Okay. All right, I'll just do this. So I'm going to do make Docker build, and I'm going to say, oops. Slash. So this is going to go ahead and generate a container that has the controller I was just running locally, but put it inside this container that I could then run inside a cluster. And so the Docker file was provided by KubeBuilder for you. This is part of setting up the project and fun stuff. And one advantage of SDKs like this is you don't have everyone making a decision about what that Docker file looks like. This is because of the tests. That's fun. So I'm going to go ahead, because I haven't updated the tests, I'm going to go ahead and remove them. All right, let's try that again. And so, unfortunately, due to the nature of how we stamp out the Docker file, if we do decide that what we gave you wasn't the best practice and update it in the future, it is hard to go and update everyone, unlike the controller runtime libraries. But at least you have something that we thought was the best thing at one point in time. And you can always look and see what the latest thing that gets stamped out and decide if you want to use that. OK, so this uses a multi-stage build. So that means it's going to have the first stage of the build, which has a containerized build. It copies all the source in there, builds a binary. And then the second stage of the build doesn't have any of that stuff as layers in the file system. It just copies the image from the first stage, and now it just has that. So it's going and building this thing called the manager, and the manager is what manages multiple controllers. If you notice, when you modify the reconcile function, you have a client provided to you. That client is provided by the manager. And it allows the wiring for setting this stuff up to be consistent and basically boring, instead of you having to make decisions about how to define functions to pass around configs and that sort of thing. Okay, so there's that copy. And then it does this kind of fun thing where it changes the image in the config file. Because I specified the image, I have this config file that I use to publish this thing, but I didn't specify the image until just now, so it does this sed to go and update that. Okay, so let's go and push that. Of course. So that's going to go push this up. There's a tool called Customize that we use for running this thing. Ooh, I forgot a step. Does anyone know what the step is by any chance? I mentioned it in passing. Okay. When this runs in cluster, it's going to, I have 5 minutes, so I'll do this quickly. When it runs in cluster, it's actually going to be running as a service account inside that cluster. And that service account has certain permissions to do things and not other things. And it doesn't have permission to do anything I haven't already given it. Unlike when it runs locally, it's using my account, which I have permissions on. And so it needs to be able to talk to stateful sets and services, right? It needs to be able to write to those things. If I do not add these lines, what's going to happen is it's going to start up and it's going to say, hey, I can't talk to those things, and get a bunch of failures. Oops. So I'm then going to do another make. And it says RBAC manifest generated. I'll skip the tests. Okay, so now I'm going to do this. So it has this MongoDB API thing, which has different pieces it's going to create. And you can pop this open later. Here's the RBAC rules, service account, different pieces it needs to run this thing. So I'm going to kube control apply that thing. I know this problem. You probably won't get this, gcloud. And there is an explanation for this. So essentially what it's saying is my account doesn't have permissions to launch this, to actually run this inside the cluster, because I don't have permissions to give these RBAC roles. Oh, yes. All right, I might be stuck here for in 3 minutes. Okay, I'm not going to try and fix this because it's going to take me more than a minute. But what will happen if I have the correct permissions on the account when it's set up is this will go and start the stateful set. Or sorry, it will go and start the controller as a container. I think it uses a stateful set. And then I don't need to run it from my laptop anymore. And then anyone can get at it. Yes? Update the manager to use the, sorry, what's the namespace?
The namespace option on the manager. It was added a little bit ago.
So I think the problem is not that I don't have access to create the namespace. Is that what you mean?
I think that the problem is that your RBAC is probably asking for cluster-wide access, which you probably don't have access to. Instead, if you only set up your list watcher for your namespace.
Oh, that's a great suggestion. Let's see if that works. All right, so that means have RBAC in here. All right. Do you happen to remember what field it is? Is it namespace? Like that?
Yeah.
All right, let's see if this works. Super hack. All right, so those are the API groups. Apps, databases, and core, or another apps.
You might also need to change it from a cluster role binding to just a role binding.
Change cluster role, you said? Oh, just to role? Yeah. I don't know. Let's try this. Let's see if it works. That field doesn't go there. Maybe if I do. Let's see. All right, I'm gonna have to check this one later. I think we're out of time. So I didn't quite make that one, but if you have your cluster set up ahead of time and you do your research, then you'll probably not have this particular problem. Any other questions? Okay, awesome. Thank you. Thanks.
Are you back for the next session?
No, I'm done.
I didn't. Sorry.
Yeah.
Testing.